We are told that there's a quadratic function, f of x equals x minus 1 squared minus 6. You might recognize that as vertex form. Great. We're told there's also another linear function, g of x equals 10, and that they intersect each other. Well, if I try to imagine what the type of a picture is, this won't necessarily help us solve it, but I think this will help us imagine it and walk us through the algebra. If you try to imagine where this parabola is going to be located, I don't know, something like that, okay? And then we have this other function, which is a straight line, a flat straight line, something like this. Okay, so we have clearly two intercept points, A and B, and we're asked to find the distance between them, or the length of the line segment that goes from A to B, in other words, the distance between them. Now, if we knew exactly what the x locations were, I'll call this x sub A and x sub B, this would be no problem. We just do xb minus xa. That's the point of this problem. We're going to have to find the x locations. So what I'm going to do to find the intersection of two functions is simply set them equal to each other. This is always the procedure. If you want to know where they intersect, you say, where are the y values equal? Okay, well, what are the y values? The y values of f of x are this, x minus 1 squared minus 6. Those are its y values. And the y values of g of x are very simple. It's just the number 10. It's always y equals 10. So now we try to set this thing equal to 0 and solve it. I'm going to break open that parentheses, and I'm going to distribute the multiplication. I'll say x squared minus 2x plus 1. That was just the parentheses. Then I have this minus 6 there, equals 10. And now I'm going to get the 10 over to one side. Say x squared minus 2x plus 1 minus 6 minus 10 equals 0. And the reason I like this equals 0 form is because that's going to let me solve for x by factoring. Now I'm overdue to clean up some things on the left side here. I can combine the plus 1, the minus 6, the minus 10 to get plus 15, I think. So we get x squared minus 2x plus 15 equals 0. And now we factor it. We get x minus 5, x plus 3. And now using the zero product theorem, you can say, okay, that equals 0. So x minus 5 equals 0. That's one of my solutions. The other solution is this right here. X plus 3 equals 0. So this gives me two things. X equals 5 and x equals negative 3. Those are the two locations where the functions are equal to each other. In other words, this is 5 over here. That's negative 3 over there. So the question is, what is the length of the line segment AB? Well, it's just the distance from XA to XB, and this looks like a distance of 8 to me. So that's what we're talking about here. Just to review, major ideas that we pulled together here. I think the most important thing is this guy right here. When you are told that two functions intercept each other, this is what you do. You set them equal to each other. That means the y values are equal, and that only occurs at certain places in x. You can find those x's using algebra.